This is Unit 1 Functions, Day 3 Absolute Value Functions. We're going to go ahead and get started with the warm-up on this lesson because we're going to see the parent graph that we're going to be using for these transformations. Number one's wanting you to actually make a table. So we're given the domain values, -2, -1, 0, 1, and 2 for the x's. And now to spit out the f of x values, we're using f of x equals the absolute value of x. If you'll recall, the absolute value, whenever you're asking for the absolute value of a number, it's asking for how far is that number from 0. So the absolute value of -2, -2 is 2 units away from 0. -1 is 1 unit away from 0. 0 is 0 units away from 0. 1 is 1 unit away from 0, and 2 is 2 units away from 0. So this completes number 1. Moving on to number 2, it wants us to graph it, which that's actually kind of handy now that we've got the table, that we can just plot those points. And what it does is it makes what looks to be a V. This function is not continuous due to the bend in the graph right there. But the domain, really quick, talking about that, don't want to leave that out, is all real numbers. And for this parent graph, the range is our set of f of x such that it is greater than or equal to 0. The domain and range is kind of similar to very similar to what you'll see for quadratic functions. And the behaviors for these functions follows the same rules whenever we start graphing them. It's very similar to vertex form. Anyways, this is your absolute value parent function. That's what we're going to be using today. The reason why this ties in with piecewise defined functions is because we had two pieces here. We have the piece on the left starting at 0, 0, going to the left, and a piece on the right going on up and to the right. Anyways, let's go ahead and get it described as a piecewise function. The piece on the left has a slope of -1, so it'd be -1x, and the y-intercept is 0. And I'm going to save on where the domain range is for just a second. The piece on the right has a slope of +1, and the y-intercept is also 0. Now, as far as the domain restrictions go, for this left one, it's any number less than 0. For the right one, it's any number greater than 0. But 0, 0 is a part of your graph, so you're going to need to include it on one of the two pieces. And it actually doesn't matter which one. So for this first one, I'll say if x is less than or equal to 0. And for the second one, I'll say if x is greater than 0. So an absolute value function is actually just a piecewise defined function is all it is. Because this is yet an alternative way to represent this same graph. Just now you would show this part that would actually end up being filled in, and then it picks up right from there for the second piece. So hopefully you see the connection between what we've been talking about previously up to this day. All right, here's example 2. What I'm going to do really quick is go ahead and throw it into the calculator. And I'm going to show you how to get absolute value on your calculator. You can actually use alpha F2 to bring up a menu of different functions that are really useful in our course. But the very first one is ABS. So hit enter on that, and we'll type in 2x. I know we don't have a t. Hit to the right to get out of that absolute value, and now you'll type in -4. And now we're ready to actually see our graph. And here's what it's going to end up looking like. And we can go to the table and get some points. Pointing out a couple things really quick. The joining of the two pieces is now not at 0, 0. It's at 0, -4. And that's because of the -4 that happened right here. It moved down 4 units. If you'll recall from your Math 2 class, you used vertex form, and that's what this is tied into. So 0, -4 is the place where your two pieces are joined together. Also, your slope has been impacted. It's now rising 2, running 1. And that's because of the 2 inside here. Technically, since it's inside the absolute value, this is not stretched vertically. Technically, it's compressed horizontally. It's been pushed in from both of the two sides. But it does accomplish the same thing as stretching it vertically. All right, we're going to go ahead and graph this out. And you could use the table on the calculator, second table, to actually get your points. And that's what I'll do here. We'll talk more about it as being a transformation further into the lesson. And again, you're rising to running 1 from the point 0, -4. And now I'm ready to actually graph in my lines. Got my 2 pieces. Now we are to state the domain and range here. For every single one of these absolute values, unless you've got a domain restriction, your domain will be all real numbers. Now for this one, your range is going to be greater than or equal to -4 is where it's starting at, but it does include -4. So I'm going to say h of t is such that h of t is greater than or equal to -4. And I'm done. All right, on this problem, I am going to use the calculator again, but just pointing out a few things first. There's a negative in front of the absolute value. This function has been negated. That tells me it has been reflected in the x-axis. So this one's going to be opening down instead of up. Next, it's been stretched vertically by a factor of 2 because of the 1/2 inside here. Or horizontally, stretched horizontally by a factor of 2. Now, you're going to think of this as being compressed vertically. It's got a slope of 1/2 at the end of the day is what it does. Also, it's going right 4 units. And up 2. Now, if you're a little leery over how I'm getting this is going back to vertex form like I said in Math 2. This is x minus h plus k. And we're going to see that on the screen coming up, but hopefully you'll get more comfortable. Let's go ahead and get this thing, though, for right now in the graphing calculator and actually work with it. All right, so going into y equals, going to go ahead and type that in there. Negative, again, to get the absolute, let me clear out. Negative alpha f2, there's ABS. And I'll go ahead and type in the 0.5x minus 4. I'll hit to the right to get out of the absolute value, plus 2. If you're using an older software on these TI-83s or TI-84s even, you'll have to actually use a little bit of a different process for your absolute value. And if you'll please bring that calculator with you, and I'll show you how to actually work with absolute value. All right, going to go ahead and graph this. Seeing it right here, and that's what I said. The slope is actually now 1/2. And you can see where it's actually gone out right here, actually further than what I mentioned. All right, so this is example 3, and what you're going to see here is we're going to have the vertex, more or less, the joining of the 2 pieces. It looks at first like it's going to be at 4, 2. However, it's not. It's actually going to be at 8, 2. And the reason is because what you do is you actually set that whatever's inside the absolute value equal to 0, and solving for x shows you where it's going to be. When you divide by 0.5, that's multiplying by 2, by the way. That's the reason why it's going to happen at 8, 2, is where this graph is happening at. Now, let's say you're not comfortable with what I've done right there. For right now, what I'm expecting you to do is use your graphing calculator, throw it in there, and see what's going on. So that's what I'm going to do now, is get this thrown to the side here. And what I've done is I've gone to y equals, gone ahead and typed it in using ABS. If you're using an older version of this calculator that doesn't have the updated software, you don't go to alpha F2. You actually have to go into math, but I can help you with that individually. And let's go to our graph and see, yep, 8, 2 is where it's happening at. And I'm going to go ahead and go to the table to get some other values. And I'm going to scroll down to where that change in the direction is. Alright, so it's at 8, 2, and then it's going down 1 over 2, and that's because of the 1/2 coefficient of x. So going to go ahead and increase the size back again. Going to go ahead and graph out the 8, 2. Then going to go down 1 over 2 in each direction. And I'm ready for my graph. And going in both directions, and there I'm done. Really quick on domain and range, didn't ask for it, but the domain would still be all real numbers. The range would be f of x is less than or equal to 2. Alright, now something that I've been kind of hitting around here that I'm really going to focus on now on the next problem is transformations of functions. At the beginning of the class, we worked with f of x equals absolute value of x. That was the parent function. Now, every function that we've been looking at could be described in one of these ways, or multiples, okay? So multiple things could be happening to it, which is what you've been seeing. So, when you're dealing with absolute value functions, it's this form right here. A times the absolute value of bx minus h plus k. Not really going to see a whole lot of b thrown in there. Not common. You will see it occasionally, though, and that deals with the graph horizontally. We saw it on the last couple problems. You'll see a good bit, where it's going to stretch or compress the graph vertically. You're going to sometimes see the whole function negated. That happened on the last problem, where it reflects it in the x-axis, and all of a sudden it's opening downward. F of negative x, not really going to happen with absolute values, because honestly, if you negate inside the absolute value, it just turns to positive anyways, and so there's no difference in the function due to its symmetry. H and k moves the graph left or right and up and down, as it says over here. This is a really good chart to have in your notes, as this chart works for every single function that we're going to be dealing with throughout this course. Here's our last problem on dealing with absolute values. What you're going to see here is actually a few transformations. First of all, the entire function's been negated. That reflects it in the x-axis. And that's because you're seeing the graph now open down because of this negative in front here. A negative inside the absolute value doesn't do that. It would just make it reflect in the y-axis, which you end up with the same thing. All right. Next, it's been compressed vertically. Due to the coefficient being less than 1, it's going to compress it vertically by a scale factor of 1/2. And lastly, it has been translated. Now, due to the fact that you don't have a b coefficient in front of the x inside the absolute value, you can actually just go ahead and take the x minus 3, set it equal to 0, so x will equal 3. That's actually where it's gone. It's gone to the right 3 units. And that's positive because of the minus h idea I showed you on the previous screen. And it's going up 2 units because of the plus 2 out on the side here. That's the k value. Now I'm ready to graph this. I'm actually going to start with where it went to. 3, 2. Graph that point. Might use a different color. Now I'm going to use this a value, negative 1/2, meaning I'm going to go down 1/2 in both directions because it's an absolute value. And there's my graph. It didn't ask for domain and range, but my domain would be all real numbers. My range would be f of x less than or equal to 2. So we did this yesterday in class, but I'm going to show it to you again now, of how to evaluate into a piecewise defined function. So somewhat unrelated to what we've been talking about throughout the lesson, but here we go. Whenever you're asked to evaluate for g of negative 3 for a piecewise function, there should only be one function that you're going to use here. And since the x value is negative 3, I would be actually using this middle one. because negative 3 is between negative 4 and 2. So that's what you got to do first, is figure out which piece you're going to use. So I know I'm going to use the expression x. So I know that g of negative 3 is equal to simply negative 3 because it was equal to x. Now I'm going to do g of 2. Going to go back up here and figure out which of these expressions I'm going to use. Now 2 is a little tricky because there's 2 of them, it looks like, but really this one's not equal to 2. So the x value is equal to 2. I'm going to need to use this last expression. So negative x plus 6. Negative x plus 6, again putting 2 now in for x. So g of 2 is going to equal 4. And now we're going to do the last one for you, g of negative 5. Going to refer up here, negative 5 is going to fall onto this first one, and it simply equals negative 3. There's actually no work to do right there because it tells you that it's equal to negative 3. And that wraps up our class. Let me know if you got any questions. Thank you.